Asigi topic sina error in measurements. Say physics ki 11th class ki unit 1 ki part amani. Say music akoi among the dimensional analysis nainagre adui makata ko ina say significant figure. Significant figure hai tadi kaino hai tadi say number of digits up to which we are sure about their accuracy. So suppose number 1, number 2, those digits that are known correctly in an experimental observation plus one more digit. That is uncertain. The example measurement we have a value 14.5 centimeter in the measurement of a length. The measurement has been met correctly up to measurement has been met correctly up to 1/100 of a centimeter. So see measurement, the measurement has been met up to 1/100 of a centimeter. Now suppose so 20 ga 20.00. What is the difference between 20 and 20.00? Aina hangta gadi se sigidi agona significant figure si 1 hai doini sigi sina significant figure is 4. There are some rules to find out the number of significant figures. So now let us go to the rules. rules to find out the number of significant figure. So number 1, all the non-zero digits are significant. Example, say 1, 3, 4, 7, 8. Suppose see masing significant figures 1, 2, 3, 4, 5. So it has 5 significant figures. Number 2, all the zeros between 2 non-zero digits are significant. For example, 12002 aitadi. So these zeros between the two non-zero digits are significant. So significant figure is 1, 2, 3, 4, 5, 5. So it has 5 significant figures. Number 3, all the zeros to the right of decimal points and to the left of first non-zero digits are not significant. For example, 0.00053. Why height adi? Zeros on the right of the decimal point and on the left of the non-zero digit, that is 5, are not significant. Aduna sigidadi, it has only 2 significant figures. And next point, all zeros to the right of the last non-zero digit are not significant. Example, all zeros to the right of the last non-zero digits are not significant. Say 1, 3, 5, 2, 0, 0, 0. See height adi. See zeros on the right of the last non-zero digits are not significant. So see significant figure see only 1, 2, 3, 4. 4, it has 4 significant figures. Next, all zeros to the right of a decimal point and to the right of a non-zero digit are significant. The example 12.3000 आदि आगे significant figures है. See 0 ohm 0 significant way. All the zeros to the right of a decimal point and to the right of a non-zero digit. Other significant figures is 1, 2, 3, 4, 5, 6. So it has 6 significant figures. Now significant figures in algebraic operations. Significant figures in algebraic operations. So number 1, addition or subtraction operation. Say example, in addition or subtraction, we retain the least decimal place the example x equal to 9.872, say y equal to 4.29. Suppose question 8 torasi x plus y, say 9.872 plus 4.29. So sigidi significant figure 3 lay, sigina significant figure 1 2 3 4 4 lay. Ada si tinjanabagi phone si say 9.872 4.29. So 9 9 10 16 8 9 10 11 14. So 14.162. So aduna akuna see why the least significant figure like ID that is 3. Aduna see akuna say 14.16. See the round torga rounded, that is known as rounding off. And they're gonna drop to the machine to 5 to be picked agati 5 to is out agati 1 tinjani aduga 5 to be you're gonna do another machine to them. So on the other hand, say x minus y haitadi 9.872 minus 4.29. So CD 5.582 tare. So gonna round toraga rounding toraga 5.58. Kaya da kuna last drop to do see less than 5 will be. While kuna cannot obey division the shoe in case of multiplication and division also. Okay, number 2 multiplication and division. Suppose x equal to 4.192, say y equal to 2.02. So we know that x has 4 significant figure, y has 3 significant figure. Now x the y na divide to rasi 4.192 divided by 2.02. So sige answer si kya tarage haida kona yen to yen kan 2.044 tarage. Other say rounding torkanta kona sige 4 is drop torani. Finally we can write 2.04. Similarly akona sige x into y, say 4.192 into 2.02 multiply tore. See multiply to matamda answer si 8.46784 tare. Other than the akona say that quite a least significant figures later. Y has least significant figures. As a way, my significant figure 3 tamam ta taragadi sigi rounding the was she gets drop to bini sigi last upon a drop to dribble digit 5 digits out of nina 1 tinjalani, so answer we can put as 8.47. So x into y equal to 8.47. Now, when I start rounding the boogie, can occur my neom curly, and they're gonna drop the group of machine do 5 commander, but not gonna 5 followed by 0. Do it among preceding number digit to be in 1 tinjanba or tinjandaba natuki can only neom lay. So if the digit to be dropped is 5 or 5 followed by zeros, then the preceding digit, Roman number 1, is not changed if it is even. So example, gonna 9.45. See 5 she dropped of it. See 5 she dropped of it na. See mamangi masing si 4 si even wave. 4 si even wave ni na. See masing si is rounded to 9.4 or 9.450 hai ta de. See koi si up see the round of the name up to 2 places digit significant figure ani khak no ka to ni 5 si drop to ni ado 5 ki mamang da leba machine 4 si even number oibani na kenta change to roi, so is rounded to 9.4. The next is raised by 1 if it is odd. So example 9.35. So koi 5 se drop to ni 5 se drop to ni aduna is rounded to 9.4 because my 5 c koi drop to 5 c ki mamangi masing se odd oibani na koi 1 tinjan gani or 9.350 itad is rounded to 9.4. Now let us come to error. Error, I say, what do you mean by error? Every measurement will have some errors. I'm going to say physics or chemistry or any science. Science I target always we deals with measurement. I don't know. Say all measurements will involve errors. The measurement may be measurement of the length or measurement of weight or any. Every measurement could have error leni. Say for example, the error की definition सी kita example में पीके example आइना हाइडो सी example say related to the error. Say for example, say if say take weight of 3.758 gram of sodium chloride. Common salt weight C low high rank. So you have given a weighing machine. Weighing machine हम ले रहे हैं electronics की weighing machine हम ले रहे हैं सीधा पान ले रहे हैं सीधा weight ची common salt ची on another सी मतलब तो paper अमा हफ्चल थम्मे paper. The weighing machine is so accurate, so it can take weight so accurately that it can measure the weight of the slip of the paper. Say for example, weight of the paper is 0.023. So this is the weight of the paper. Adoi say 8, 9, 10, 11, 5, 6, 7, 8, 7, 3 gram. Ana sita nana sigi option do si 7, 8, 1. Si display toro kupak si weight half kade. Ham dan kitang weight si option lani. Option gan suppose sorak per 2.532 gram and tole. Karam option le 3.534 tole. Karam option le 750 kain thole kitang hapsan ganda 823 kain thola hen grane kitang wale na hapsan le hen grani hen gribasi lok thue amu wala ni ado I don't know, you cannot accurately measured sigi weight nang exactly weight on bangamoy say by mistake or luckily accurately measured. But when you transfer to a crucible, chemical kind of compound saduni, and see the crucible transfer to matamda piece of paper to the some molecules of sodium chloride. So when pahogane, other than kaiguba chemical ama sabada or compound ama sungna honabada darkar level way to accurately on by si oithokte not only for the synthesis of the chemical compounds when electronics ki say diode hyro transistor hyro sigi the p type n type kana noi tamni go me am sindu da doping to matamda we add different materials by measuring accurately, by taking accurate weight. Ado hapchalakanda doping to duni high temperature the synthesize to duni aduna mad accurately on by there will be always some errors. Aduni another example I get. Suppose you have a furnace and you want to maintain at 100 degrees Celsius. So furnace ki temperature is 100 degrees Celsius to maintain to pami. We connect a coil heating element coil nama samay coil ama samjale, then current pisale, so that because of the heating effect of current, heat increase. Say room temperature dagi, say some 23 degrees Celsius some temperature say increase tore say 90 or 90 days some increase tore 95, 96, 97, 98, 99, 100. 100 again you're gonna op, you want to op the circuit, so you connect a relay switching, say relay switch, so that the current is off when the temperature is 100 degrees Celsius. 100 degrees Celsius or op tone lagna ring ida sigi furnace sigi temperature je 1.101 102 103 yorani op torani, then op toramni na amuk kadore temperature ji reduce torani, reduce toropasina 103 dagi reduce toropasina 102 101 100 100 tagi 99 98 97 aro nana 100 ta maintain to bo pamba je sigi furnace sigi temperature je 10 plus minus 3 degrees Celsius is the very torani, means 97 degrees Celsius to 103 degrees Celsius the maintain the open. You cannot exactly maintain the furnace at 100 degrees Celsius. It is not possible to maintain at 100 degrees Celsius, but temperature will vary between 97 degrees Celsius and 10 degrees Celsius. So error is also associated. 100 the maintain the 100 plus minus 3 while in have. So we will consider different types of error. So first error is true value minus measured value or observed value. So error is defined as the difference of true value and the measured value. Now what are the types of errors? Types of errors. So errors we can classify it into two types. One is systematic error and another is random error. So systematic error errors are always in one side. If the error is always in one side, so I am going to measurement any measurement henjan ba waro natu ba ke waro error is always in one side. Systematic error code. And systematic errors we can classify it into instrumental error, instrumental error maroina koina zero of the vernier scale not coincide with zero of the main scale. Matam sida I think main scale gi zero ga vernier scale gi zero ga coincide to do. Matam sida instrumental error is totally. Or in another case, if the pointer of the wing machine do not set to 0. Matam sida instrumental error lai. Then second type of systematic error is personal error. Personal error is because of the limitation of the observer. And next is natural error, or we can say environmental error. Such type of error arises due to change in conditions. Due to change in conditions. So, for example, if we measure the melting point of ice under normal pressure, we are doing an experiment to find out the melting point of ice under normal pressure. So that if the pressure changes due to some reason, then the melting point of ice will differ. Another case is, so in the experiment of Ohm's law for measuring resistance, we are doing an experiment, Ohm's law for measuring unknown resistance. Say ammeter to measure the current flowing through the resistance, we connect a voltmeter to measure the potential difference across the resistance. Now, Ohm's law na hai ji, V is directly proportional to I at constant temperature. Constant temperature, the V equal to Ri. Now, if the temperature of the resistance changes, then Ohm's law ki kanosi resistance to change the oragati because of the change in temperature. Adana akoina own gadu accurately on Bungamaroi. Such type of errors are known as natural error, means error is due to the change in conditions or change in environmental conditions. Now in the other case, the random error is because of the unknown causes, or this is also known as chance error. Say, for example, we consider a simple pendulum. The bob is making a to and fro motion, simple harmonic motion. So we can calculate the time period, where L is length of the pendulum, G is acceleration due to gravity, and T is time period. And we know that time period should be independent of the amplitude. Hello, Kegumba. Siki vibration jita Kegumba atop condition factor mayamna change to holagati koi time period on by do accurately on bagamoy. So such type of errors is known as random error. Now, how to express error? Errors can be expressed in different ways. Error can be expressed in different ways. So let us take an example. So let x1, x2, x3, x4 xn be the observed values of a physical quantity. Then mean value is, so mean value is x bar equal to x1 plus x2 plus x3 plus xn divided by n. So this we can write as 1 by n summation xi, where I is from 1 to n. So this is known as mean value. Then absolute error. Absolute error is difference between mean value of the physical quantity and the observed value. So delta x1 equal to x mean value minus x1, delta x2 equal to x minus x2, delta x3 equal to x bar minus x3, and so on. Delta xi equal to x minus xi. So mean absolute error delta x bar is delta x bar equal to mod of delta x1 so this also we can write by 1 by n summation delta xi, where I is from 1 to n. So hence final result of the measured physical quantity is x equal to x bar plus minus delta x bar. So final result we can put like this. Now we can express also relative error. Relative error is the ratio of the absolute error to the true value of the physical quantity. So that is absolute error divided by true value. So relative error we can represent it by del x. Del x equal to del x bar divided by true value is x bar. And also we know we have percentage relative error. Delta x percent equal to delta x bar divided by x bar into 100%. Now we can take up an example. Say exercise. Acceleration due to gravity. G is measured as 9.88 meter per second square, 9.78 meter per second square, 9.91 meter per second square, 9.89 meter per second square, and 9.77 meter per second square respectively. Find value of G absolute error, relative error, percentage error. So in the measurement of acceleration due to gravity, it may be by using simple pendulum. A student did the experiment 5 times, and these are measured values. In the first experiment, 9.88 meter per second square, second experiment, third experiment, fourth experiment, and fifth experiment. He got 5 different values of acceleration due to gravity. Now, so mean value of G is G bar equal to G1 plus G2 plus G3 plus G4 plus G5 divided by 5. So this is 9.88 plus 9.78 plus 9.91 plus 9.89 plus 9.77 divided by 5. So it comes to be 9.84 meter per second square. Now, absolute error. So, delta G1 equal to G bar minus G1 equal to G bar is 9.84 minus 9.88, so it is 0.04, and delta G2 is G bar minus G2 equal to 9.84 minus 9.78, so this is 0.06. Delta G3 is G bar minus G3 equal to 9.84 minus 9.91 equal to minus 0.04. 7. Delta G4 equal to G bar minus G4 equal to 9.84 minus 9.89 equal to minus 0.05, and delta G5 equal to G bar minus G5 equal to 9.84 minus 9.77 equal to plus 0.07. Now min absolute error is delta G bar equal to delta G1 plus delta G2 summation delta G3 plus delta G4 plus delta G5 divided by 5. So this is 0.04 plus 0.06 plus 0.07 plus 0.05 plus 0.07 divided by 5. So this is 0.058. Now this 8 is rounded, so it becomes 0.06. So this is delta G bar. Hence the value of G is G equal to G bar plus minus delta G bar. So this is 9.84 plus minus 0.06 meter per second square. Now we can find out the relative error. So delta G equal to G bar divided by G bar. So this is 0.06 divided by 9.84. So this is relative error, and percentage relative error is delta G percent equal to 0.06 by 9.84%. Now we come to a combination of errors. So let delta A and delta B be the absolute errors in the measurement of two physical quantities A and B. So number one, when the result involves the sum of the two physical quantities, Z equal to A plus B. Then considering the errors Z plus minus delta Z equal to A plus minus delta A plus B plus minus delta B. So A plus B plus minus delta A plus delta B. So maximum possible error is delta Z equal to delta A plus delta B. Adakona masingani tinjana matamda error su tinjanani. So number two, when the result involves the difference of two physical quantities, Z equal to A minus B or Z plus minus delta Z equal to A plus minus delta A minus B plus minus delta B. So A minus B plus minus delta A plus delta B. So in this case also the maximum possible error is delta Z equal to delta A plus delta B. Ala keguma masingani ke difference lo matam da su ketore error do tinjanani. So for example, say L equal to 25.03 plus minus 0.01 centimeter. Say L2 equal to 15.02 plus minus 0.02 centimeter. And the rod anigi, there are two rods. One of the length is L1 and another is L2. So this is L2 and this is L1. Now number one, L1 plus L2 put ho gaya tali 25.03 plus minus 0.01 plus 15.02 plus minus 0.02. So this is 25.03 plus 15.02 plus minus 0.01 plus 0.02. So this is 500,234 plus minus 0.03 centimeter. And number 2, say L1 minus L2 is 25.03 plus minus 0.01 minus 15.02 plus minus 0.02. So this is 25.03 minus 15.02 plus minus 0.01 plus 0.02. So this is plus minus 0.03. Masingani tinjana batasu error tinjanani adagi difference low kandasu error tinjanani. Number 30, when the result involves the product of two physical quantities. For example, Z equal to A plus A not plus A into B. So this also we can write A plus minus delta A into B plus minus delta B. So relative error delta Z by Z equal to delta A divided by A plus delta B divided by B. Percentage relative error. So delta Z by Z percent equal to delta A by A plus delta B by B percent. And number 4, when the result involves the ratio of two physical quantities, that is x z equal to A by B or A plus minus delta A divided by B plus minus delta B. So in this case also the relative error is the delta Z by Z equal to delta A by A plus delta B by B, and percentage relative error is delta Z by Z percent equal to delta A by A plus delta B by B into 100. Now, when the result involves the powers some physical quantities. So number 1, z equal to a to the power x. Then in this case, relative error equal to x delta a by a, and percentage relative error equal to x delta a by a into 100. And second case, so z equal to a to the power n, b to the power n, c to the power p divided by e to the power q. Then for this relative error, delta z by z equal to m delta a by a plus n delta b by b plus p delta c by c plus e q delta e by e. Percentage relative error is delta z by z percent equal to m delta a by a plus n delta b by b plus p delta c by c plus q delta e by e into 100. Si mathangda koi problem mamang da NEET ta hangiba question kara dum ai upload torke si makada mathang adagi noina kaigumba singnaba noina angingba leraga sotum question taro amuka noina noina so mathang ai upload torke mai mathang yengu aduga comment subscribe to kaugunu